Let's look at this set. Jayant, a mathematics teacher, had 30 students in his class, and they sat in chairs arranged in 5 columns in 6 rows. He wanted to distribute some chocolates to the students in his class. However, he wanted to give more number of chocolates to the students he liked most and fewer chocolates to the students he liked least. Basically, the teacher discriminating among the students. And as much as I would like to say this doesn't happen, it is human nature. You like some people more, you don't like other people. The factors based on which you like and dislike, they can be judged. But the fact that teachers end up liking some students more is definitely true. But to conceal this discrimination, he devised the following method to distribute the chocolates. Okay, so he's being smart. He's hiding his discrimination by some mechanism. Starting from left to right in each row and from front to back, he gives chocolates to every 7th student. After reaching the last student, that is the student in the rightmost column and the last row, he continues counting from the first. That is from the leftmost column and the first row, but does not count any student who had already received a chocolate. He keeps giving chocolate to every 7 students that he counts in this way. Further, to the first 5 students that he gives chocolates to, he gives 2 chocolates each. The next 5, he gives 3 chocolates each. To the next 5, he gives 4 chocolates each, and so on till he gives 7 chocolates each to the last 5 students. Now see, once you read through the initial bit, the first thing you realize is you have to make a 5 by 6 table here. You have to make a 5 by 6 table here. Otherwise, you won't be able to get to the answer. In addition, look at question number 7, question number 8 within this. How many pairs of students sitting immediately next to each other in the same row or same column received the chocolates, one immediately after the other? So you also have to see at what point do students get chocolates, as in the receipt number. The first person to get it, the second person to get it, the third person to get it, the fourth person to get it, even that has to be tried. So there is a lot of work here. You have to make a table. But when you're making that table, please make sure you make a huge table. Something like this. Here, I'm going ahead and naming this. This is row 1. This is row 2. This is row 3. This is row 4. This is row 5. And this is row 6. This is column 1, column 2, column 3, column 4. And I have messed up. I should have included one more column. But we can do that now. Let us make this column 5. Okay, we'll manage. Okay, column 5. Now, when our friend is, or when this teacher is giving out, Jayant, I think, Jayant is giving out chocolates. Every 7th kid he gives chocolates to, and he starts from the leftmost column, the first seat. See, this is where the teacher will stand. This is where the leftmost column and everything will start. So 1, 2, 3, 4, 5, 6, 7. This fellow will get 2 chocolates and he is the first to receive chocolates. 1, 2, 3, 4, 5, 6, 7. 2 chocolates, second fellow to receive it. 1, 2, 3, 4, 5, 6. 1, 5, 1. 2 chocolates, third fellow to receive it. 4 and 3. 2 chocolates, fourth fellow to receive it. 2 and 5. This fellow will receive 2 chocolates and he is the 5th fellow to receive it. And we know after every iteration, 5 times he has given 2 chocolates. Now when he starts giving chocolates, he will give 3 chocolates. So 4 and 3. So this will be the fellow who gets 3 chocolate and he is the 6th person to receive it. Then 1, 5 and 1. So this fellow will get 3 chocolates and he is the 7th person to receive chocolates. 3 and 4. This fellow will get 3 chocolates and he is the 8th person to receive it. 4 and 3. 3 chocolates, 9th person to receive it. 1 plus 3, 4. 4 plus 3. Again 3. And this will be the 10th person to receive it. Now, 4 chocolates have to be distributed to every individual. 2 and 3, 5, 5 and 2. This fellow is he will get 4 chocolates and he's the 11th person to receive it. Then 1 plus 4, 5 plus 2. This will be the 12th person to receive it. 1 and 3, 4. 4 and 3, 7. So this fellow is the 13th person to receive it. 1 and 3 and 2 and 1. This fellow will be the 14th person to receive it. 3 and 2 and 2. 4. This fellow will be the 15th person to receive chocolates. Continuing in the same vein, 1 plus 3 plus 3. 5 chocolates, he will be the 16th person to receive it. 2 and 3, 5, 5 and 2. This is 5 and 17th person to receive it. Then 2, then 3, then 2. Again 5, and this is the 18th person to receive it. 2 and 3 and 1 and 1. 5, and this is the 19th person to receive it. 1 and 3, 4, 5, 6, 7. 5, and this is the 20th person to receive it. 3, 1, 1, 5, 2. This fellow will get 6 chocolates. He's the 21st person to receive it. 1, 2, 3, 4, 5, 6, 7. So this is 6. This is the 22nd person to receive it. 1, 2, 3, 4, 5, 6, 7. 6. 23rd person to receive it. 1, 2, 3, 4, 5, 6, and 7. This is the 24th person to receive it. 1, 2, 3, 4, 5, 6, and 7. This is the 25th person to receive it. And now, whoever is left, that person will get 7 chocolates each. So first thing I will do is I will fill up these pots with 7. Oh, I will not fill up these pots with 7 because I also need to know which order they are getting it in. 25th, then 1, 2, 3, 4, 5, 6, 7. 7, 26th person. 1, 2, 3, 4, 5, 6, 7. So this will be 7, 27th person. Then we come back here. 1, 2, 3, 4, 5, 6, 7. 7, 28th person. 1, 2, 3, 4, 5, 6, 7. 7, 29th person. And finally 7 to the 30th person. We not only have an entire pool of who got how many chocolates in which seat, we also know when they received it, the order in which they received it. Okay, so the first one, what is the maximum number of students sitting consecutively next to each other in the same row who received the same number of chocolates? In the first one, we have no consecutive numbers being distributed. In the second row or row 5, we have 5 and 5. Row 4, we have no such instance. Row 3, we have no such instance. Row 2, we have no such instance. Row 1, we have 6, 6, 6. So 3 kids, or option B will be the answer here. Next, what is the total number of chocolates received by the students sitting in the 4th column from the right? Sitting in the 4th column from the right. So when I'm looking at 4th column from the right, remember it is 2nd column from the left. So people in this column. So 6 plus 2 is 8. 8 plus 4 is 12. 12 plus 6 is 18. 18 plus 7 is 25. So the answer should be option D, 25. Next, how many pairs of students sitting immediately next to each other in the same row or the same column, received chocolates immediately one after the other. Okay. In the column, let me see if any pairings: 27th, 3rd, 26th, 19th, 22nd, 14th, 24th, 1st, 15th, 21st, 7th, 11th, 4th, 30th, 10th, 6th, 12th, 23rd, 25th, 9th, 2nd, 13th, 18th, 20th, 8th, 16th, 29th, 20th. Yes, this is a pairing. This is a pairing. So 20th, 29th. This is a pairing we have identified in our column checking. Now let's do row checking. We have 23, 24 in the same row. And anything else? No, I can't see any other pair. 28, 29 in the same column, received chocolates immediately after one another. And 23, 24, same row, sitting next to each other and received chocolates immediately after one another. So two such pairs. How many pairs of students who received chocolates one immediately after the other were also sitting in the same column? Okay. So this time not necessarily as in not necessarily the next seat, not necessarily in the next seat. It is just that you have to receive it. And okay, so if I have 27, let's say I have 27, I will count this 27 if I see a 26 in the column or if I see a 28 in the column. I see along with 26, the 27, there is a 26. This pairing is already accounted for. With 3, I will count it if I see a 4 or a 2. And I see neither. With 26, I will count it if I see a 27 or a 25. 27 pairing already mentioned. 25, I can't see. With 19th, 20th, or 20 or 18. Nope. With 22, 23 or 21. Nope. With 14, of course, no point. If I have checked this far, I don't need to check anymore. 11th के साथ I need 12th or 12 or 10. Nope. 7 के साथ I need 8 or 6. 8 or 6. No. 21 के साथ I need 22 or 20. No. With 15 I need 16 or 14. No. With first I only need second. No. With 24th I need 23rd. No. With 4th I need 5th. No. With 30th I need 29th. No. With 10th I need 11th or 9th. No. With 6th I need 7th. No. With 12th I need 13th or 11th. No. With 22nd, 23 I need 22 or 24. No. With 25 I need 24 or 26. No. With 9 I need 10 or 8. No. With 2 I need 3 or 1. No. With 13th I need 12 or 11. No. With 18, I need 19 or 17. No. With 20, I don't need to check. I've checked all others. So with 20, I need 19 or 21. No. With 8th, I need 9 or 7. No. With 16th, I need 17. Yes, 16 and 17 are in the same column. But 15 is not here. 29 and 28 are here. 29, 28 done. With 17, 16 is already recorded. With 5th, I need 4. So there are 3 pairings now. There are 3 pairings now. How many pairs of students who received chocolates immediately one after another were also sitting in the same column? There were 3 pairings. 27th kid, 26th kid, 16th kid, 17th kid, 29th kid, 28th kid. There are 3 such pairings. And that is the entirety of this set. This is a set that doesn't require a lot of interpretation, but careful numeric processing and recording everything appropriately. Once you do that, it should be fine. It also helps if you read through the subparts earlier, because otherwise, most likely what would happen in the first iteration, people would simply write down at what spot how many chocolates are being obtained. But for the subpart 3 and subpart 4 of this set, you need to also know who received chocolates at what position, as in when did they receive the chocolates? Are they the first to receive it or are they the 15th to receive it? Until you have that information, the last 2 subparts can't be handled. So that has to be recorded right from the beginning. That is all for this set.